are we doing today? Well, this is going to be a fairly quick one. This is an extension lead. You have probably seen them before. This one is not in great shape. You can probably tell from the marks in there. It'll become more apparent as we get it open. Today I'm going to do something illegal. I'm going to change the plug. Why is this illegal? Because I'm not an electrician. I have my AS3760 or AS-NZS 3760 test and tag ticket, but that doesn't make me an electrician, and it doesn't authorize me to change these, not at least in the state I'm in. But it does authorize me to test and tag these and make sure they're safe. In any case, this will get run by Sparky before I, Sparky being a slang term for an electrician, it'll get run past them for approval before I use it, even though I'm pretty sure I know what they're going to say. But you check with these things anyway. So, before I get started here, don't do this at home. It's dangerous. Australia uses 240 volts, and it can and will kill you if you screw this up. So, just don't do it. Anyway, that being said, we're going to go ahead with stuff I've said don't do. Let's get this plug out. The first thing I'm going to do is open this, check the wire cutting guide, because that is going to tell me a nice little scale diagram of how much I need to cut, and also how the strain relief works in the plug. I like these ones specifically because I can see what's going on in there, and I can see if the earth wire specifically has pulled off. That's a major thing. Fun fact, these cables have a stripe in them so that you can tell if they have been twisted, and if you roll them up wrong, they will twist. Generally, the first wire to pull out is going to be the earth wire, and you won't know that's out there until something electrifies you, like a vacuum cleaner pack that is stuck to the back of a cleaner. These days, with mandatory RCDs, or basically earth leakage protection devices, with them being mandatory in places and pretty much everywhere, it's fairly hard to do that, but it can still happen, especially if you get a reverse polarity plug on that and your vacuum cleaner has a grounded chassis, and then the neutral becomes the active, and so does the case through the MEN link. Anyway, I'm going to cut this thing off, autopsy it, and put a new one on. I wish I had brought my big cutters. I could have done this in one cut. Anyway, we'll autopsy that in a minute. We want to have a good look here, make sure nothing's corroded up in here. And we are going to just gently nibble away from the outside of this stuff. And we're going to need to go around about that. Is going to be about right for our total length. How's that? I eyeballed it exactly the right length. You'd almost think I've done this before. Anyway, we're going to bend this a bit, and we're going to separate this cable off. Sometimes it takes a little bit to nibble around here. I do have proper tools for doing this. Like a little sheath cutter. The problem is that sheath cutter is very difficult to get calibrated to different types of cable, and it does tend to nick the inner insulation. Anyway, we'll be back in a moment once I've got this off. Now, one of the reasons why I have just stripped off a whole bunch more using a different, safer technique is because it's very easy to nick the inner conductor, especially with sheath cutters, but also with the method I'm using. So I've abandoned that. I also like to remember a little phrase here: black and blue, red and brown. Black and blue is what you're going to be if you get this wrong. Red and brown are usually the hot wires. They are active. Black and blue are neutral. And your green or your yellow or your stripy wire is earth. Don't get them backwards. It's a bad idea. So we are going to go here, and we're going to trim all our cables off about there. And we're going to strip off the copper by about 9mm there. Should be just enough. Should be about right. Cool. These are very sharp flush cutters, and what I'm doing here is doing a squeeze in two directions and then just gently holding them while I pull the end off. Proper strippers will probably do a better job of that. There is a potential, if you do that wrong, that you can cut all the conductors off. Again, a dangerous out. Pretty much any time you make a mistake with this, the consequences can be dire. So You're going to hear that a few times from me. Anyway, let's get this disassembled. The other reason I much prefer these plugs than the plastic ones is I'm not having to poke around the edge of this plastic stuff, or the rubber stuff here, with a screwdriver and scraping it around things. These seem like a much better idea. The downfall of these plugs is it's much harder to trim off this little shroud here, which for plug packs and stuff like that can be necessary. But for what I'm using this for, that is not going to be an issue, and I will plug a power board in if I have to. And that will add some protections of various sorts when I do that. These usually have to come out quite a long way. Okay, we are open. Before we do much else, let's put our cable gland on. Alright, we're going to omit this cable gland. The main reason being is the cable gland is about the same diameter as the cable going in. Either case, this is on here, and I'm going to slide that way down the cable, because that's always the bit that I forget when I'm not doing this. Something else that is also the case with these is these screws come done up so they don't rattle out in transit. And I'm sure it's somewhere in those AS/NZS 3760 standards or the AS3000s somewhere, the reason why they use a flat blade screwdriver, but they still do. So I'm going to open all of these up, and that will help reduce me burring or splitting off those conductors as they go in. Okay, now I generally like to start with the active wire so that I don't get it too wrong, and it tells you here the brown wire is the active, and it goes to A for active. And I'm trying to find where it's written on this. There we go, A on the top of this one right here. So the brown wire is going to go in there, and we're going to put that in here. The other thing to remember too is the direction of the cable matters. If you put the plug in the socket on the wrong end, you're never quite going to get these cables to flip over the right way. There's a good reason for that. My old man, who was an electrician, he also taught me that one, along with a few things. It still never quite figured out how it works. Something to do with the twist in the cable, because it is kind of like a twisted pair network cable in the way that the twists work. But yeah, there is a right and a wrong end to put a plug on. Who would have thought it? Put our earth wire in here, which is quite clearly marked with a green dot. Pretty hard to miss that one. And that's probably because that's the important one. So now, we've got little strain relief. I've got the two strain relief hooks there. We need to go under for those two. There we go, one under that side, one under that side, and the earth has its own one somewhere too. There we go, earth has one there. That helps prevent you ripping the plug out, and now we've got to put our strain relief on. The way these things work is pretty straightforward. Hook it round, put it on the back, do the screws up. You'll see in a minute. Alright, we have our clamp on, and it's just not enough to destroy or damage the cable, but enough to get a good grip on it. Now we find our shroud, which is way down the cable. Alright, here we go. Now, find the correct orientation to put this in, and we push in. Hopefully we're correctly aligned, which can be a little tricky. There we go. We are in like Flynn, as Dave from EV Blog says. Do this one. But yes, as I said at the start of the video, I know several electricians, and I don't do anything like this that doesn't pass muster in their eyes. That being said, I've spoken to electrical inspectors before, because I've been on sites with them, and they say that the best way they tell when somebody has done their own stuff is when it's too neat. And I have seen Sparkies do some shocking things. Not the ones I've worked for, but some of the competition, I have seen some shocking licensed work in roof cavities that I wouldn't go anywhere near with a 20-foot pole, even if it was insulated. So anyhow, I'm going to put this over my test and tag machine, test it, make sure it's safe, and run it past my Sparky mate. In the meantime, we're going to autopsy this one and find out what went wrong with this. Pretty sure I found this plugged into a heater. Now this one is very old and not very elastic anymore, but we can probably work our way around here and get this one out. Takes a bit of practice to get these things out. You've got to work your way around, break the seal on this, and then try and work it up a little bit at a time. I'm not worried about breaking this one, so I'm being much more forceful than it would be with a new one. I could just cut it to pieces, because I don't really think we want to reuse this. Give me a few minutes till I get this out. Alright, this one was getting so old, hard and brittle, I decided to just sacrifice the plug because it was probably not safe to reuse anyway. That's why we were replacing it. So we have two brown marks here. I did a little bit of screwing around with a screwdriver here, so it's messed up that a little bit, but we can see straight away that the active wire was not in that clamp very well. So this is not one that I wired, by the way. Well, okay, this is pretty indicative of why I'm replacing it. I knew something was wrong in here and it didn't test properly either. So yeah, glad we are replacing this lead. Well, that really wasn't making much contact at all. That's just fallen out. So I think anything I'm doing here is probably better than this. This was definitely a fire risk. I am pleasantly surprised to see that the earth wire, well, okay, I'm not so pleasantly surprised to see that. But yeah, this was definitely a fire risk. So very glad to have that gone. And I'm going to bet that in here these contacts are probably not much better. I wonder if I can open this up. Some of these you can. Let's see if we can actually have a look at those contacts. Separate the two halves. Alright, so this is one of the contacts. This has got a fairly good bit of copper on it. Not all of them have this kind of contact. But yeah, that is definitely oxidizing and has been arcing. This one, the contact in there looks alright, but this is probably the earth connection. Where's our other one? No, this is definitely the earth. This is the clean one. So it was definitely a neutral that was not looking good. Anyway, I'm going to turf all of this because it doesn't need to go back together again. But you can fairly clearly see what was going on in there. I might even make a thumbnail out of that. Don't know yet. Alright, we'll see you in the next video. I hope this was an interesting one. But definitely if your leads are misbehaving or things are not quite working right, probably check them out. Get them tested or get yourself a new lead. Alright, see you later.